Hi, this is Leah Henson. This is my question for midterm 3. I was given question 15.158, which asks for the accelerations of each of the points within this disk. If each point has a relative velocity of u in reference to the disk, and the disk is rotating at a speed of omega. Actually, no, if the whole system is rotating at the speed of omega. And there's no angular acceleration. So when using this equation, I simplified it in all these cases. So for the first, second, and fourth, since these are all rotating at the same speed, and there's no at a constant speed, it's just because of the positioning of them, there's no relative accelerations for these 3 points. So you can go through the same process when you're solving for each. So the acceleration of the first one would just be 2 omega across the u minus omega squared times the radius of 1 with respect to the origin. So your acceleration of the first would be omega squared times the radius in the I hat direction minus 2 omega u in the j hat direction. And then the same process for the second one. So you get acceleration of 2 is 2 omega u I hat minus omega squared r j hat. And then skipping over to 4, you do the same process, and you get acceleration 4 is equal to 2 omega u plus omega squared r, all in the j hat direction. 3 is a little bit different because there would be a relative acceleration of 3 because it has a circular path. So the relative acceleration would have to be equal to the normal acceleration. So in the negative I hat direction because the origin's over here. And so your relative normal acceleration would be minus u squared over r I hat. And so then you do the whole process again, but you add this. So your acceleration for 3 would be negative u squared over r plus 2 omega u plus omega squared r, all in the I hat direction. And that's the whole thing. Thanks.